right, in our last example then for section 2.1, we're actually going to talk about and generate a histogram for a different data set. The following data set represent the number of calls from motorists per day for roadside assistance. So in order to create our histogram, we're going to start with a frequency and relative frequency distribution. Then we're going to create a histogram and relative frequency histogram below. All right, so again, kind of reminding us of what we're thinking about our interval notation. Right, in this first class from 25 to 50, right, we're going to include the 25 but not include the 50. Right, so then we're going to go 50 to 75, same thing. Right, so square bracket in the beginning means that that first value is included. The parenthesis at the end means that that last value is not included. All right, so I'm just going to go ahead and finish filling the rest of these in here. Okay. All right, so now our frequency. We're going to go through and we're going to count our data values. Unlike the other data sets that we've looked at where things were kind of in order when we were looking at the one for our soccer players, this is just a random list of data values. So as you go through, if you're working through something like this, it may be beneficial to you to go through and mark through or cross off data values after you use them. I'm going to go through and just put a little dot next to the ones that I've used. That way we make sure we get everything. The other thing we can do is looking at this, we have groups of 3. 1, 2, 3, 4, 5, 6, 7. So we know in the end that we should end up with a total of 21. Right? So before we go on to finish our problem, we're going to make sure that one, we get all of our frequencies in here. They total 21 values because that's how many data values we have there. All right, so from 25 to 50 really means we're going from 25 to 49. We have this value of 28, this value of 40. That looks like it, so we have a frequency of 2. From 50 to 75, but we don't want to include 75. It looks like we only have 1. We have that 70 there, so we have a frequency of 1. 75 to 100, we're going to include 75 but not 100. We have 75, so 1, 86, 2, 80, 3, 90, 4, 82, 5. Again, we don't want to include the 100s, so we have 5. 100 to 125. It's going to include our 108, 1, 122, 2, 100, 3, 100, 4, 104, 5, 120, 6, too big, 105, 7. All right, 125 to 150. What do we have here? We have a 145 and a 130, so that's 2. 150 to 175. We have a 170 and 174, so that's 2. 175 to 200. We've got a 194, so that's 1. And 200 to 225, we have our 217, so that's 1. All right, we're going to go ahead and go through, double check, add these up. 2 plus 1 is 3, plus 5 is 8, plus 7 is 15, plus 2 is 17, plus 2 is 19, plus 1 is 20, plus 1 is 21. So we have all of our data values accounted for in our frequency distribution. All right, now that we have all of our frequencies, we're going to find our relative frequencies. Remember, it's by dividing our frequency by our total. So 2 divided by 21, 0.095. 1 divided by 21, 0.048. 5 divided by 21, 0.238. 7 divided by 21 is 0.333. All right, 2 divided by 21, same as our top row, 0.095. And then 1 divided by 21, same as that second row, 0.048. So we have our frequency and relative frequency distribution. All right, so now we're going to go through and we're going to construct our histograms. I'm just going to kind of lightly sketch these in with pencil, so that way I can kind of clean up and make sure the lines are nice and straight when we're done. But this will at least give us an idea of what we're doing. Our first class here from 25 to 50 had a frequency of 2. So we're going to take and we're going to draw a bar up to 2. Right? Then from 50 to 75, we have 1. So we have a bar at 1. Then we go up to 5. Right, then we go up to 7 for the next one. Right, on the left, we're only labeled in even numbers, so the odd numbers in between it, I'm just kind of guessing there. Our next one, we have 2. Our next one, we also have 2, and then our last couple values are 1. So there is our frequency histogram. Our relative frequency histogram is going to have a very similar looking shape. Not exactly the same, but we're going to graph our percentages or our relative frequencies. So 0.095, that's really, really close to 0.1, right, or 10%. 0.048 is really close to 5%. 0.238 is going to be somewhere between the 0.2 and 0.25. 0.333 is going to be all the way up here. Right. These next two again are close to 10%, or the 0.1, and the last couple close to 5%, or the 0.5. Right. So again, I just kind of sketched it out in pencil because I'm going to go through and fill it back in. Using ruler just to make it look a little bit nicer, so that when you look at the notes online, it should be filled in. But that gives us an idea of how we can go through and we can sketch these. All right, now our advantages of histograms. They are good for large data sets. So they're good for large data sets. Shows the general shape of data, and it's easy to spot data that does not fit the pattern. If we were to do our histogram for our soccer goal data, or thinking about that histogram that we saw of our soccer goal data, we did have kind of one little value hanging out, one bar that wasn't really connected to the rest of our histogram. Disadvantages of histograms. Individual data values are not visible. Right, so we can't see that we had 2 that were exactly at 100, right? That we had one value of 120 or whatever we're looking at, so on and so forth. So that is one disadvantage to histograms, to where our dot plots and stem and leaf plots did show actual data values. And then shape can be affected by bin width. So when we're going through and we're constructing these, that is something that we want to keep in mind. But histograms are by far what we're going to use the most, and we're going to continue talking about through the next few sections, or next few chapters, I should say. So histograms are definitely something that is going to be kind of a reoccurring theme. A lot of times it's going to be a way data might be presented to us in the future. We might be looking at data in the future.